Okay, hello everyone. This is number 6 of the chapter 11 HL test review. Number 6 gives us the probability density of a function of the random variable x is given by this equation. F of x equals k over the square root of 4 minus x squared for for the domain from 0 to 1. Alright, so basically that's just telling us that most of the curves under this so the area under the curve from 0 to 1 equals 1. Now, find the value of the constant k. We already know that the area under the curve from 0 to 1 equals 1. So the 1 equals the integral from 0 to 1 of this equation. That's how you find the area under the curve. So that gives us k over 4 minus x squared dx. We can take the k out because it's a constant, so we don't need to worry about that. Now this is because you can't really find the derivatives of a constant, it just stays a constant. That's 1 over 4 minus x squared dx. Now if you look back in your formula booklet, there's one standard integral it gives you, or the integral of 1 over square root of a squared minus x squared dx equals arc sine x over a plus c. Alright? Now, this equation perfectly matches with 1 over square root of 4 minus x squared. Um, so we can rewrite this as 1 over 2 squared minus x squared, right? So a equals 2. Okay, now that just gives us our integral of that is arc sine x over a, and we said before that a is equals 2. From 0 to 1, and that equals 1. Now let's rewrite this. 1 equals k times the arc sine of 1 over 2 minus arc sine of 0 over 2, which is this 0. Okay. Alright. How do you do this again? Arc sine for when 1 equals, it's 1 over 2. That's just pi over 3. No, that's pi over 6 minus from 1 sine 0, 0. Right? Because on our unit circle, when this is 1 over 2, this here is pi over 6. Alright. Okay, so 1 equals k pi over 6. Therefore, k must equal 6 over pi. And that's part 1. Find the value of constant k. K equals 6 over pi. There we go. Okay, now on to part B of number 6. Show that EX, the expected value of x, which is just the mean, equals 6 times 2 minus root 3 over pi. Okay, so now let's figure out what EX is. That's just in a continuous random variable. That is the integral of x times f of x. Okay? So now here it will be since k is 6 pi, it's x times f of x, 6 over pi for k, over root of 4 minus x squared dx. Alright, since k is still a constant, we can leave that out. Oh, and this is from 0 to 1. Remember, our domain is restricted. X 1 over root 4 minus x. Okay, so since this is a bit complicated, I'm going to do u substitution and let u equal 4 minus x squared. Therefore, du dx equals negative 2x. That's just the derivative of this. Alright? So if we plug that in, that's 6 pi times integral from 0 to 1 of x. Alright, now we know x here. We can rewrite this as du dx divided by negative 2, right? So du dx negative 2, 1 over 4 minus x squared is u, so the root of u d, there we go, dx. Alright, now these two dx's can cancel out, so in the end we have, oh, and this negative 2 is also a constant. You can write this as 6 pi negative 1 over 2 du 1 over root u, right? So we can move the negative 2, 1 over negative 2 out. That gives us 6 pi times negative 1 over 2. To the integral, it's not from 0 to 1 now since everything's in u. This is still an x, right? When x equals 0 and x equals 1. Well, since we no longer have x and x, we need to change all that to u. So when x equals 0, like in x equals 0, then u equals 4 minus 0, 4. If x equals 1, then u equals 4 minus 1, 3. Right? So now we have 4 to 3. Okay, this can be rewritten as, this is u to the 1 over 2 power, and it's also negative because it's in the denominator du. Now, once we can integrate that, let me say this is negative 3 over pi, right? Integrate that, that will give us you subtract 1, right? Alright, so to integrate u negative 1 over 2, you add 1 to that, so that's just u 1 over 2. And you have to multiply 1 over 2 with something to cancel out, so it's 2u 1 over 2. It's from 4 to 3. Okay? So now we can bring the 2 back out because 2 is still a constant. More room. That equals negative 3 pi times 2. Alright? U 1 over 2 from 4 to 3. So that gives us negative 6 over pi. 3 1 over 2 minus 4 1 over 2. That's just negative 6 over pi root 3 minus root 2. That's just, again, negative 6. Oh, my bad. Root 4. So that's just a negative 6 root 3 minus 2 over pi. And I think that's our answer. Yep. Wait. Yeah. We distribute the negative sign. We can also get, oh, my bad. Negative root 3 plus 2, right? And so that's how they had it. There we go. There's our proof. Alright, so we're done now with part B. Okay, so now we're in part C. Determine whether the median of x is less than half or greater than half. Okay, so when the median, to find the median, we're just going to divide the area under the curve by 2. So we want to find x when the area from 0 to x is 1/2 instead of actually 1. So let's do this. 1/2, just like what we did in part A, we're using the integral. That's from 0 to whatever the median is. Let's call this m, k, which is 6 over pi. Forget 6 over pi over root 4 minus x squared dx. Now 6 over pi is a constant again, so we can move that out. 1 over 4 minus x squared root that dx. And we solved this in part A before. This can just equal this part. When we integrate it, that is arc sine x over 2. Right. From 0 to m. And this equals 1/2. Alright, that's pretty easy to solve. Let's move the pi and the 6 over. I don't know if that's going to help. Pi over 12. Yep, let's move pi and the 6 over. Equals arc sine m over 2 minus arc sine 0 over 2, which equals arc sine m over 2. Alright, what's the arc sine of 0? 0, the sine of that, the height of 0, so that's just 0. Arc sine of 0 is 0. Okay, so pi over 12 equals arc sine m over 2. Well, so m over 2 equals sine of pi over 12. And sine of pi over 12 is, oh man, let me check my formula booklet. Sine of pi over 12 is sine of pi over 6. No. Yeah, it's equals sine of pi over 3 minus sine of pi over 4, right? Because pi over 3 is 4/12, and pi over 12, 4 pi over 12, this is 3 pi over 12, and when we subtract that, that's just pi over 12. So there's a formula for this, I just forgot. Alright, whatever. No, my bad. It's not sine pi over 3 minus sine pi over 3 minus pi over 4. There we go. Let me pause for a moment. Okay, now I've finally found my equation. That's just, so this is sine pi over 3, pi over 3 times cosine pi over 4 minus cosine pi over 3 times sine pi over 4. Alright. Sine pi over 3 is root 3 over 2. Cosine pi over 2 is root 2 over 2. Minus cosine pi over 3 is 1 over 2. Sine pi over 4 is root 2 over 2. So we have here sine root 6 over 2 minus root 2 over 2, which equals root 4 over 2. Is that correct? No. Which equals root 6 minus root 2 over 2. That's sine pi over 12. So m over 2 equals root 6 minus root 2 over 2. So m equals root 6 over root 6. Now, okay, and once I plugged that into the calculator, I did that behind the scenes here, I got 1.035, and that is greater than 1/2. Therefore, m is greater than 1/2. Alright, that's the median of x is greater than 1/2. Finally done with this question.